Welcome to Unit 4-3. Today we're going to be multiplying and dividing rational expressions. Multiply and divide rational expressions. We were simplifying before. Now we're going to go ahead and multiply and do a little bit of dividing. Here's a math career for you. A petroleum engineer. It looks like an impressive structure there. Petroleum engineers search the world for reservoirs containing oil or natural gas. Natural gas is an up-and-coming topic looking at our energy needs. Here's your salaries. Of course, they start pretty strong and only get stronger. And there's the math you might need there, well, that you will need to pursue this career. This is going to be a growing field there in that natural gas business, I'm pretty sure. All right, and there's some more information for you. And if you like some more detail, just let me know. All right, standard 13.0, students add, subtract, multiply, and divide rational expressions and functions. Today we will learn to multiply and divide rational expressions as stated earlier. So the rules for multiplying rational expressions are the same as the rules for multiplying fractions. Remember, with multiplying fractions, pretty simple stuff. Multiply the numerator, multiply the denominator. Reduce somewhere, either before or after. You multiply the numerators and you multiply the denominators straight across. Multiplying and dividing is like a shooting gallery. There's no real specific order. You can just take them down one at a time. Because you're using multiplication, the commutative property is in play there. Okay, so we just ping, ping, ping them out. At times you can't really factor, and it does become like a shooting gallery here. So if we were to do this, I'm just going to start looking for things that are in common. Maybe 8 and 16, maybe 5 and 10. I see some, what else do we see here? See, that's going to reduce, the y's, the x's, what else we got here? This looks like quite a mess. Look at all that. Okay, so we finally end up with x squared times y. Look at that. The 8's cancel the 16, and the 10, and the 5, and the y's top and bottom, and the z's top and bottom, and the x's top and bottom. And we just start reducing everything down, and lo and behold, look what we're left with. X squared y. Now, you can take another procedure. You can multiply first and then simplify. Maybe this might be something you like better. Instead of doing all that little detail work, how about this? What's 8 times 10? And what's 5 times 16? A little calculation there. Look at that, 80 over 80. How many x's do you have? 2. How many y's do we have? 5. How many z's do you have? 2. And now that we've got all these set up, now it's pretty easy to reduce. It's certainly simple to see the 80's cancel. I don't see any x's in the denominator, but I do see some y's and z's. So the y's will reduce, the z's will cancel, and now you're done. Now either way you go, notice we end up at the same spot. So if you like to reduce first and then multiply, that's fine. Multiply first and then reduce, that's fine too. End up at the same destination. I prefer the second one myself. I like to multiply, I get to see some nice easy numbers, reduce. If you need a calculator to multiply some larger ones, no problem. Just grab one and go. Alright, there are problems where you can factor, like this one. If you look here, x minus 1, can't reduce that, or factor, can't factor 2, can't factor 4. But how about this guy, 3x minus 3? Well, here we can factor right here where we can. Let's take a 3 out of that denominator. So I'm going to end up with 3 factored out, which leaves me x minus 1. And look what we can do now. X minus 1's cancel, and the 2 and the 4 reduce. Okay? So the 2 and the 4 simplify, x minus 1 simplifies, and I'm left with an answer of 2/3. 2/3. Can you think of an excluded value? Well, if I ask you for an excluded value, which we will on occasion, consider all the way back to our first expression here. If we ask you to simplify this, this of course is the number 2, so really nothing we can do there, but what about this 3x minus 3? What value for x would make this denominator 0? So you can write 2/3. What high school teacher may say, state the exclusion, and you would have to say in this case that x is not allowed to be what number? Maybe you said 1. Because what's 3 times 1? 3. And what's 3 minus 3? 0. So we couldn't allow x to be 1 in that statement. Okay? Alright. How about this? Now, oh boy, there are other problems where you can factor a lot. So you've got 3m over 6m plus 18 times m squared minus 7m minus 30 over m squared minus 100. I think I'm seeing a evil twins down here at the bottom, right? Perfect square, subtraction. So jot this one down in your notes. This is a really healthy example for you to see. What I'm going to do first here is start factoring. So maybe I start over here on this side. Can't do much with 3m, but what about 6m plus 18? Can I factor a 6 out? I think so. What about top and bottom here? Well, this is an easy x. We can do that. We know how to do those already. And this is a difference of squares. So when you look at this, don't get overwhelmed by the expression initially. Just take it one piece at a time and break it down. And now start canceling. What can we cancel away here? Looks like the 3 and the 6 can reduce. That's good. M plus 3 cancels M plus 3. That's good. M minus 10 over M minus 10. And now what are we left with? Well, it looks like 1 and an M. That's about it for the numerator. What is the denominator? 2. So this is a one way to write it down. High school teachers probably going to want this answer here. What do we do at the bottom? We distribute that 2 through. All right? So we take this really intimidating looking problem, factor them all down to small pieces, and then reduce. No big deal. And that's it for Unit 4-3. If you like more instruction, take a look there. Make sure you give us a question for the next time we see each other, okay? All right then, we'll talk to you soon.